Hello and welcome back. Today we're going to do another episode of Old School Cool, and we are going to take a look at an old Milwaukee model HS-114. Now we've looked at the S114 before, but this is the HS-114, and this is unique because it is actually 600 RPM faster than the S114. Now, this is something that's kind of unique with older tools, and you'll see here on the nameplate, here's your HS-114. You can see 2500 RPM here, and full load RPM is 1450. This is a 1/4 inch drill, and it talks about the motor current and all that stuff as well. That's interesting because if you take a look at the S114 that we've done a video on before, you can see that the full load RPM of this, while it's worn off, is 1100, and the no load RPM is 1900. This motor has a lower current draw because of the gear reduction. This is also a 1/4 inch drill, and if you look at the two of these, other than this one having been restored by me, you'll see that they're very, very similar. This one is basically untouched. I got it in this condition, and this thing is what I would call somewhat of a survivor tool. The only thing that I think I really plan to do with this at some point is put a new cord on it. This cord is still okay, and we'll go with it until it's not okay, but you can see these two tools are very, very similar, and other than what we fixed up on this, they're basically the identical tool. So the biggest difference between them is this has a different gear set in it, which allows it to spin faster. Also creates a little bit higher current load. Now, why would you need to buy a different RPM drill? That's one of the interesting things with old school drills. You ordered the drill to the speed that you needed for your application. They did not have variable speed, and there was no way to get variable speed. So if you squeeze the trigger, you get what you get. Now, some guys years ago used to throttle the trigger, and that carries through that you'll see some old timers with a cordless throttle the trigger, but that comes back to these tools where you could try and vary the speed. And we could take a look at that with the tachometer, but what you're doing is turning the tool on and off and just giving the motor a shot to slow it down a little bit. So if the tool's a little bit too fast, you could slow it down that way, and that's really the only way you could try and get somewhat of a variable speed out of these old tools. So you would order the drill for the speed that you want. Now, these are 1/4 inch rated tools, but if you're drilling something smaller, say you're drilling 1/4 inch with this, you might be drilling 3/16 with this. And then there was a 5000 RPM model that maybe you're drilling 1/8 inch with. So all of those different RPMs, from here you go to a 5/16 drill that's a little bit higher or lower speed, and then you'd have a 3/8 drill, the 1/2 inch drill, the 5/8 drill, all the different sizes, but each one would go down in RPM. So I think that's something kind of interesting on older drills. There is a plethora, there's many different RPMs available in these drills. Now, taking a look at the HS-114 here, this one is as I got it. I cleaned it up a little bit, but it is very much untouched. It's in very good original condition. I don't know if it originally had a Jacobs 1B or 7B chuck on it. The 1B is a little bit smaller profile, which is okay. It closes to 0, just like the 7B does. This chuck had a little bit of dirt on it. I cleaned it up roughly. Wasn't too bad. The brush holders and everything are in good shape. The comm and everything looks like it's in good shape. If I run it, while you see some arcing on the comm, that's normal. You don't see excessive arcing. So this is actually in pretty good shape. I don't think this was really run hard. There was a bunch of adhesive in this area, so I don't know, this may have been set up on a drill press or a polisher at some point in its life, and I think somebody had this button pressed in with tape because this button's kind of rusted and there was a bit of a mess here on the tool. So I have a feeling this was somebody's benchtop tool that didn't see a whole lot of use by hand, which kept it in reasonably good shape. It having the higher RPM kind of helped it out a little bit as far as doing a specific process. So speaking of that higher RPM, let's go ahead and see what this old tool is still able to put out. Now what we're going to do is we're going to put, I don't have a key for this chuck, so we're just going to try and get it tight. We're going to put our 7/8 socket in a 1/4 inch driver, and we're just going to run it with the Vita root, and we're going to see what RPM we can get out of this thing. Try and hold that so I don't have a glare, and let's see what we get. So we have a little bit of a wobble with that socket on there, but you can see the Vita root, we're getting our rated 2500 RPM out of it, which is really neat because that's what this tool is rated for, and it is putting out what it is supposed to. Now an interesting question would be, how much do these old tools weigh? They're all aluminum, they have a fair amount of mass to them, and we can get out the Harbor Freight scale here and take a look at, if you were manhandling this thing all day long, how much weight would you be holding? Now I don't have all of the cord on it here, but you get the idea. We're right around 85 ounces with this drill. For a 1/4 inch drill, that's pretty heavy. For comparison, we happen to have one of the newer M12 3/8 drills, and that is less than half. And I would be willing to bet this drill is going to have more torque than this old drill. And the reason why I'm saying that is because this is utilizing a 3-phase motor. Any of your brushed tools are universal motors for the most part, and any of your brushless tools are actually 3-phase motors that they have an inverter in the tool to turn the DC into AC to run the AC 3-phase motor. The universal motor is self-commutating, and what that means is it basically mechanically rectifies the AC coming in into DC. Now as tools get newer and get variable speed, you have to feed a variable speed corded tool with AC. But this tool, I don't know if it says it on it, let's take a look. It does. If you look on here, this tool says voltage AC or DC 115 volts. So this tool will run on a direct 115 volt DC source, or it will run on 115 AC and use that commutator to create the DC that the tool's actually running on. Whereas this tool uses this DC battery to make AC to run the motor. So it's kind of a little bit inversed unless you're running this on straight DC. Now these old tools are an awful lot of fun to play around with as long as you keep in mind what their intended use is. Would we want to drive 1/2 inch heavy fasteners with the 7/8 socket with this drill? No, I can hook it up to it, but it isn't going to be happy doing that. That's not what it's designed for. If you're drilling a bunch of holes or something like that, these can be really handy to have around because you can get them cheap and you can set them up for a process, and if you don't mind the cord, you can have different size drill bits in various tools. And if you're doing a multi-step process with what you're screwing around with or making, you can still use these old tools and they hold their own just fine. It's just you have to take into account what they're designed for, much like the people who designed the tool did. And that was why they sold so many different RPM options, because the tool was basically made for a purpose. So you had to do a little bit more research back then. You didn't have the variable speed trigger like you have on these now that give you a pretty wide speed range. Okay, so just for the fun of it, we have the RPM testing socket in our new 3/8 Milwaukee drill, and this drill is rated at 1500 RPMs. So let's just see if we can get our 1500 out of it and compare to the old school one. So you can see we definitely got our 1500 RPM out of it. So that means that this tool, the old one, is going 1000 RPMs faster than this one. So now if you've ever tried to use a modern cordless drill in the high speed to do something, you'll start to understand why this is a specialty tool in its day. That 1500 RPMs is pretty fast for heavier drill bits and stuff like that. The 3/8 drill bit, you really wouldn't want to run it at 1500 RPM. So you can see why these things, although they're the same family as it were, they are not the same. Let me know your thoughts below. Have you used many of these old tools? Now, some of the older 1/2 inch or what have you, we always joked around and called them wrist twisters on the job. This drill in particular isn't gonna quite have the torque that's gonna be required to do the proverbial wrist twisting, and the size bit that's in it, you're going to be able to hold the drill, and if it digs in, you're going to break the drill bit. But as these got bigger and had more geared down gear sets in them and got the 5/16 or the 3/8, the half, especially when you're getting to 5/8, 3/4, even some of the Morse taper 1.25 inches, you better be holding on, because you're going to go for a ride with those old tools. And that's where some of the old tools have a lot of torque comes from. Not so much with these old 1/4 inch drills. You got to be careful with them if you play around with them, but they're an awful lot of fun if you're using them for what their intended use is. So let me know if you've used any of these 1/4 inch tools in your career at some point, or if there was an old timer that had one in his tool carry. They're kind of unique. They do the job. This is a non-reversing drill whatsoever. This button that's on here holds the trigger on, and I can demonstrate that. You can run it, no hands. That makes safety guys happy, I'm sure, in today's day and age. But these tools also had multiple other uses. They had drill press fixtures for them. They had a few other rigs that you could set up with these tools and use it as a multi-use tool. So the ability to lock the trigger on was a handy thing. Plus, if you're out of position drilling all day in manufacturing, you might not want to hold the trigger all the time. So kind of interesting, a little bit different culture in the era of this, which I believe is going to be in the early 1950s, somewhere in there. I've seen some older catalogs that have these tools that look like this, and they were like 52, 53, somewhere in there. So this tool is 75 years old. So it's pretty impressive that it still runs. Can we say that about one of these 75 years from now? So let me know what your thoughts are on these. I find these old school tools a lot of fun to play around with in the shop. I don't get to do it as much as I'd like to, but here you have two models of the 1/4-inch drive Milwaukee drill. We took a look at this one in another video. Here's the higher speed version. I thought it'd be fun to kind of take a look at them and do a quick compare and show how this runs. These are one of those things, if you can get a good deal on them, they're fun to play around with. They're easy to take apart and clean. They're parts, you got to be a little creative sometimes to get the right parts and everything, but it's doable. You can get the parts for them and still use them, as you see we're doing here. So as always, thanks for watching, and have a great day.